All right, Matthew, here we go. We got lesson 2.1.4, proof by contradiction. Okay, so what we've been doing before with our flowcharts are more like direct proofs, where we try to prove things and then come up with statements. Everything flows from one statement to the next. Now, that's not the only way to do a proof. There's different types of proofs, and one of them is proofs by contradiction. Now, as far as all the lessons that we cover, this is probably, for this unit, probably one of the least important ones. So don't stress if you don't completely understand it. Personally, I think it's beyond the scope of where you're at right now in math. You would probably see this more at a collegiate level even. But anyways, we're going to just kind of, we're not going to breeze through it, but I'm going to just kind of show you a different way that you can write a proof. For more advanced style proofs, proof by contradiction is really helpful, but for where you're at right now in math, probably not so helpful. But anyways, the book has it, so I'm going to do it. Here we go. Okay, proof by contradiction. So in a proof by contradiction, you try to prove something's true by trying to prove it's false. Does that sound crazy? It is a little bit. So here's what happens, is you come to a proof and you're like, I'm trying to prove this is true, but what if it wasn't true? And so what you do is you go, okay, what if it wasn't true? And then you kind of follow through and say, okay, if it wasn't true, then this would happen, then this would happen. Then at some point, you're going to get to a point where you're like, you know what, this doesn't work. And you're going to prove that the opposite doesn't work, therefore it must have been true the whole time. Confused yet? All right, sounds good. All right, so let's start looking at this problem here, and hopefully this will kind of explain what we're doing. Right here, I've got two parallel lines with a transversal, and X and Y, we have named these types of angles. These are same side interior angles. So those are same side interior. And even from the last lesson on converses, we were saying that the relationship between same side interior angles is that they are supplementary. So write a conditional statement. Well, we said if lines are parallel and they're cut by a transversal, then same side interior angles are supplementary. All right, so if two parallel lines, I'm just going to do the symbol for parallel right there. If two parallel lines cut by lines are cut by transversal, then one of the things that we know is true is that these same side interior angles are supplementary to each other. All right, so, and we proved this before because remember we used like, what did we use? We could use alternate interior angles, we could use corresponding. Anyways, with corresponding angles, this angle's X, and that would mean this angle down here is X, right? Because corresponding angles are congruent. And then we would see that the X and Y are linear pairs. They should add up to 180. So that's why X plus Y has to equal 180, because we got corresponding angles here, then linear pairs. So that proves corresponding angles are congruent. So we know it's a rule of math, which we know that the converse works for this. So yes, the converse is going to be true, and the converse would just be if same side interior angles are supplementary, then the lines cut by the transversal are parallel. All right, so that's true. And we talked about that on the last lesson. That's definitely true. What would a proof by contradiction look like in this problem? Okay, so what would a proof by contradiction look like? It would look like this. We would try to prove the opposite of what we're saying here. So a proof of contradiction, if I look at this statement, if two lines cut by a transversal, then same side interior angles would not be supplementary. They don't add it to 180. So that's what it would look like. Somebody's knocking on my door. Just a second. Sorry about that. They were trying to give me bagels, which I guess is a good thing. Anyways, here we go. So what would a proof by contradiction look like? We would try to state the opposite of what we're saying here. So our first step would say that the same side interior angles are not supplementary. But that's kind of hard to prove that the same side interior angles are not supplementary. So let's instead try to prove that the lines are not parallel. So we could do either one. We could take the converse and try to disprove it, or we could take the conditional statement and try to disprove it. Because remember, in math, they have to work backwards and forwards. So the other thing that we could try to prove is that the same side interior angles are supplementary, then the lines are not parallel. And this is actually going to be the easier one, just trust me on that, to prove than this one. So this is what I'm going to try to prove. So our first step for a proof by contradiction is to try to prove the opposite. What if it's not true? So it's kind of crazy. Anyways, we're saying that they're going to be parallel lines, and then we're saying, but what if they're not? All right, so now we're going to try to prove that this is not true, that lines are not parallel. That's our goal. I want to prove these lines are not parallel. So Maria decides to use proof by contradiction because she's crazy. She thinks it's easier to use the numbers instead of variables, which is fine. So she goes, okay, here I've got same side interior angles, and they're supplementary. So she's starting off with this converse and saying same side interior angles are supplementary. And then our other statement said the lines cut by the transversal are parallel. But she's like, but what if they're not? What if they're not parallel? Because we're doing a proof by contradiction. Okay, so why are AB and CD intersecting? Why is AB and CD, this line here, why are those two lines intersecting right now? Because Maria's trying to prove they're not parallel. Which is kind of crazy because she knows they are parallel, but she's trying to prove they're not. Okay? So now we have this assumption. What if they're not parallel? And now we're going to follow through that assumption until we get to the point where we're like, wait a second, this doesn't work. So her next step is to find out what the measurement of angle BED is. BED is this angle down here. Okay, so this angle down here, we want to find out how many degrees it is, because she's saying, what if they're not parallel? Well, these two are supplementary, because remember, we keep the hypothesis and we're changing the conclusion to do the opposite. Well, if this is 100 and this is 80, we should be able to find this angle because of the triangle sum theorem. The triangle sum theorem, remember, states that the sum of the interior angles adds up to 180 degrees. Well, this is 100, this is 80, that's 180 already. So that would mean this angle is 0. That's crazy. Angle BED is 0 degrees. You can't have an angle that's 0 degrees. That's crazy talk. And that's what our contradiction is. She has just proven that you can't do this. She tried to do the opposite, and it's not working. So that's your goal, is to do the opposite and make it not work. I told you it was crazy. So her contradiction is that angles can't be 0 degrees. So since we can't have a 0 degree angle, this proves that these can't not be parallel. They have to be parallel because otherwise we would get 0 here. That's our contradiction. So that's why it's called proof by contradiction. You try to prove the opposite, work it out, show that it doesn't work. That's your contradiction. And therefore, what you were trying to prove the whole time was true. There you go. Usually when we use proof by contradiction, we do not use numbers. We use variables to show that it's going to work for any numbers that we can think of. So in the diagram, we've got angle YBA. So YBA would be this angle right there. So that angle. And we've got angle BAZ. This angle right there. Okay, those two angles are same side interior angles. Now we're calling BAZ X. So if angle BAZ is X and these are same side interior angles, then we would end up calling YBA using that X variable. We would call this, since these have to add up to 180 minus X, or 180, so we would call this 180 minus X, because now if you add them two together, the X's cancel and you get 180 degrees. So this angle would be 180 minus X. Okay, what is the opposite that we're trying to prove? We're trying to prove that the lines are not parallel. Okay, so the opposite of what we're trying to prove the lines are parallel. So the opposite of that is the lines are not parallel. So remember, our goal here is to do the opposite and show it doesn't work. And if it doesn't work, then what we were trying to prove in the first place is true. That's really confusing. Whew. Okay, so draw a new diagram and prove that to prove and show that there is a contradiction and this doesn't work. So the new diagram would look like our last one, where we've got, here's A right here, so this is the X. We said Z was right there-ish. B would be right up here. But now instead of proving that they're parallel, we're trying to prove they're not parallel. And so this angle up here is the one that we just called 180 minus X. Now remember, we're using variables just to show that it works all the time. On the previous problem, we used two angle measurements, 100 and 80. Really, all we proved with this one is that it doesn't work for angles that are 180. So what if you had other angles like 110 and 70? Does it still work for those? So when you use variables, you're showing that it always works all the time. Okay, so using the triangle sum theorem, since we now have this other angle over here, the triangle sum theorem would say that X plus, should we name that one? Oh, that one would be like Y over here. This would be angle Y over there. So X right there plus this angle right there plus the measurement of angle Y is equal to 180 using triangle sum. So that's a rule of math that we can use. I'd combine my two like terms right here and here, and I'd get 180 plus the measurement of angle y equals 180. I'd subtract 180 from both sides and get the measurement of angle y is 0 degrees again. Now I did it all with variables, so now that proves it works for any combination for those two angles. So that is my contradiction. Angle y cannot be 0 degrees. The measurement of angle y cannot equal 0 degrees. I have a contradiction. Therefore, I've proven that the lines aren't parallel, that's not true. So if the lines aren't parallel, that means the lines were parallel the whole time. So since we have a contradiction, our conclusion is the lines are parallel. We tried to prove the lines weren't parallel. It didn't work out for us, so that means the lines must be parallel. That is what proof by contradiction is. So yeah, enjoy that. Have fun with it. See ya. Bye.